just like this, except I put only 2 problems on the front and 2 problems on the back. Here I put them all 4 on the front side. Otherwise, it's exactly the same. The directions are exactly the same. So, here we go. Number 1, solve by graphing. Now, I told all your parents last night, and I've told you like infinitely many times, you gotta have a calculator. If you are going to come in and rent one from me, that is absolutely fine, but you're going to pay 50 cents.
Can we pay in advance?
No. I'm not a bank. I'm not a store. You'll come in with your 50 cents. We're going to solve by graphing. Okay? Now, listen. We're going to solve by graphing. We first of all have to think of this as y equals, because that's the way it's going to go into our calculator. What window are we going to start with when we graph these? The standard window, which is what? X min and Y min are both -10. X max and Y max are both +10, and the scale for X and Y, X scale, Y scale is 1. That's called the standard window. Chances are that will be good. Okay? So I'm going to go ahead and put this equation in. X squared, and we've talked about lots and lots of times. You get X from your variable button. That's how you put an X in. So we type in the equation and hit graph, and you should see something that looks like this.
What's the X min supposed to be at?
-10. Now, what points am I interested in that picture? Okay, what points am I interested in? I'm interested in x-intercepts. That's exactly right. I am interested in this point and this point. So, who remembers how we find this? 1 at a time. Second calc. 0. Move the cursor using your arrow buttons so that it is over here somewhere. This is you're looking for this point. This is the left. This is the right. And then I'm going to put it between there. I got -4.701562. That's exactly what you should have gotten. Anybody confirm?
On the test, if we write, is it okay if we just write 4.7, or do we write?
There will be rounding instructions. Okay? Now, I need to find this one. How do I do that? Start over. Second calc. 0. Now my left bound is over here. And my right bound is over here. And that 0 is 1.7015621. Okay? Next, solve by completing the square. Well, you've had a quiz over this, so you should be good at this. 12 by completing the square. Step 1. Divide by 2. Step 2. Add the 5. Subtract the 5. And the reason we subtract the 5 is so that we can add something to both sides. What are we going to add to both sides? 4. And how do we know we're adding 4 to both sides? Because half of 4 is 2, and 2 squared is 4. Zach Bond, you remember that?
Yeah, I already did.
Oh, you already did that? So what did this come out to be, Zach?
X minus 2
Yep,
squared.
yep. Equals -1.
Yeah.
Oh, that's kind of bad news, but we can deal with it. Taking the square root of both sides, x minus 2 equals plus or minus, what's the square root of -1? I. Very good.
X equals 2 plus or minus I.
Yep. And those can't be added together, so you don't have to break that apart. You can just stop right there, right? Anybody have an issue? What did we learn on the quiz we took the other day? If this guy, if your radical breaks down, make sure you break it down, right? Quadratic formula. You're going to have plenty of room. Like I said, I only put 2 problems on each side on the real quiz. So if you want, you might want to write the formula. What is the formula? Brokaw, did you bring a pass in? Where'd you come from?
I was just trying to make cunning hand.
Just like.
Yeah, I didn't have a pass. No.
What's our formula?
For quadratic?
Yeah.
Opposite of b plus or minus b squared.
Square root of.
Square root of minus 4ac over 2.
There you go. So if you don't have that guy memorized already, you probably want to get that memorized so that you can do the problem. Claire, where have you been? Where did you show up from? No.
It wasn't. Yeah, on the schedule it said the class didn't start until 9:30.
That's fine. Yeah, tomorrow. Tomorrow you were forming the service.
Look at you, man.
I don't know, the bell rang.
Yeah, that's what I was confused about.
You please that line?
We don't need to schedule, we're good. Okay, now for my problem, what's A? B is, and C is 1. So now I'm just going to plug them in. 5 plus x equals 5 plus or minus the square root of 25 minus 4 times 3 times 1 all over 6. Does that look okay to everybody? Now what's underneath that radical? 25 minus 12, which would be 13, which kind of makes me happy because I don't have to worry about breaking it down, right? There's my answer. And then number 4. This is what we just did yesterday. Who remembers from yesterday what we do? Erica?
You have to move the 2 over.
You do. So we're going to subtract 2 from both sides. and that will give us 8 over here.
Squared.
Now we remember we're going to square both sides. So 3x minus 1 equals 64. 3x equals 65 and x equals 65 thirds. Now what's the extra piece? Always when you do this process, we have to check it because sometimes we get what? Extraneous roots, right? So we don't know, so we have to work it out and see. When we check it, we go back to the original problem, the very original problem. And where there's an x, we're going to put in 65 thirds. Now, before you start like freaking out, what's 3 over 1 times 65 over 3? Just 65. Don't panic, that's just 65. What's 65 minus 1? 64. What's the square root of 64? 8. What's 2 plus 8? 10. Does this check? Yes. So that's our answer. No, I did not square root. I squared. There's a difference. Oh, you mean here, the square root of 64? No, the rule is when the radical is already in the problem, it has a plus sign before it, that's a positive radical. Only positive. Sometimes they could have a minus in front of them, and then it's just a negative. You only do the plus or minus thing, like if you had x squared equals 25. When you put the radical in, then we have to do the plus or the minus. When it's already in the problem, it already has a sign.
Okay, so it's good, it's just good, but then how do you know the difference between extraneous and then no solution?
No. There's no difference. If this had not worked, then it would be called an extraneous solution, and the answer to the question would be no solution. All right, put that away. That's what you have to do on Mondays. Everybody clear on that expectation? Yes. Okay. Then get out your note sheets. We've got a lesson to do. Yeah, we're going to look at E6 today, which I think you will enjoy. Okay, this is one of the easiest things we've done all year. You're going to remember this, and it's easy to start with, and you've already done it before, so it makes it really easy. We're going to add these two complex numbers together. And when we add them, we add like terms. In other words, it is as easy. Why is this soaking wet?
Oh, because I have my water on it. Sorry.
It is as easy as it could possibly be. See this 3 and this 2, you're going to add them together. See that I and that minus 4i, you're going to add them together. That's all there is to it. It's so easy, I don't even know how to teach it. It's so easy. You just collect like terms. Add the numbers together, add the i's together. Doesn't that make sense? Yeah. Now this is exactly the same thing, but I do have a caution for you here. See that minus sign? What's that going to do? It's going to change it all. So it's going to be 4 plus 3i minus 6 minus I. That negative distributes through just like negatives always distribute through. So then what's our answer going to be? Negative 2 plus 2i. Kids, if you make that hard, I'm gonna be so mad. It is easy. That is easy, easy, easy. Anybody have an idea how to do C? But how do you think we're gonna multiply these, John Brokaw?
It's like boiling.
We're going to FOIL. That's exactly what we're gonna do. We're gonna distribute, John, the real name for it's distribute. Foiling is what we call it, that's all the same. We're gonna use the distributive property, we're gonna FOIL. So first times first, 12. Outside times outside, negative 9i. Inside times inside, positive 8i. Last times last, negative 6i squared. Can these two be added together? Yes. They're both plain i's. They can be added together. So we have 12 minus I minus 6i squared. Now someone impress me. What do I do with I squared? Carrie?
Didn't you just get rid of it?
Well, I substitute something in. Jake Hill.
It turns into like plus 6 plus 6. Plus
Because I squared is
One.
negative 1. Boys and girls, look. In a problem we did a minute ago, we noticed that I is the square root of negative 1. So if I square that, what happens to the radical and the square? They cancel, don't they? So I squared is negative 1. You need to remember this. Put a star by it. You need to remember that. Every time you see an I squared, you are going to plug in negative 1. Right? So like Jake said, this becomes negative 6 times negative 1, so it's a plus 6. So what's my final answer?
18 minus I.
18 minus I. Lexi? Where?
With the with the I,
Okay, I squared is negative 1.
Okay.
We're gonna memorize that.
Okay.
We're gonna put a box around it, put a star by it.
Yeah.
And every time we see a negative 1, or every time we see an I squared, we're gonna put a negative 1 in its place.
Okay.
Negative 6 times negative 1 is positive 6.
Okay, that really helps.
All right, now I need somebody else to impress me. How do I handle this? Lindsay. Hey, this group back here, I can't even hear Lindsay because you're making so much noise. And probably you should be paying attention. Go ahead.
If you multiply 6 minus I to the top and the bottom.
I am going to multiply something to the top and bottom. That is exactly right. It's not 6 minus I, though. It's 6 plus I. I am going to multiply the top and the bottom by what is called the conjugate. The conjugate of 6 minus I is 6 plus I. If I had a problem where I had this, then I would multiply the top and the bottom by the conjugate of this, which would be 7 minus 2i. When you do the conjugate, you just change the middle sign. Now you'll see why in a minute, why we do that, but that's what you do. So this was 6 minus I, so I'm going to multiply the top and the bottom by 6 plus I. Okay? Now, look at that numerator. Didn't we just do a problem that looked like that, the numerator? So what are we gonna do here? FOIL, distribute. Guess what? We're gonna do the same thing on the bottom too. We gotta do the top and the bottom. So this is a big problem. Here we go. FOILing out the top. First times first, outsides, insides, and last. Now we'll fix that, we'll clean that up in a minute, but let's get the foiling done. Now on the bottom. First, outside, inside, last. Do not even think about canceling anything this way. No, 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 no. However, we should be thinking about simplifying in our top and our bottom. So can anybody see something that combines up there on the top? These are gonna add together, and that would give me 23i. Exactly. What does this become right here?
That becomes
-3. Plus a 30, so that gives me 27. This is -3 because I squared is -1. Every time I see an I squared, I put in a -1, so that becomes -3. Now what happens on the bottom? These go away, right? That's the beauty of the conjugate. It gets rid of the i's. What about -I squared? Plus 1. So on the bottom I have 37. Now I want to talk a little bit about canceling here. Obviously nothing cancels in that problem, but if we had something like this. Kids are always tempted to cancel here. You can't. The only way you can cancel in a problem like this is if you can cancel out of everything. So here, 6, 12, and 8, I could take out a 2. So that would be 3 plus 4i over 6. And that's fine. Here, you cannot cancel anything because the 7 doesn't participate. So don't be tempted. Okay? How about E? What do you think the answer to E is? I bet you know. 9i. 9 because it's the square root of 81, and I because there's a negative.
Wait,
Yeah.
I have a question on the last one before.
Uh-huh.
How did we get 6 over 6 plus 7i? Because we're at 27.
Oh, no, that was a different example, I'm sorry.
So that was.
I was showing, this is the answer.
Alright, cool.
Yeah, I was showing you about canceling.
Alright.
Yeah, this is the answer to the question. All right, F.
Is it -6?
It is, Moses. Because, what's the square root of -4? 2i. And what's the square root of -9? 3i. So what do I get when I times those together? 6i squared. I squared is,
-1.
Ms. McDowell, what are you doing? I squared is -1, so our answer would be, as Moses said, -6. Jamal?
Is this just a coincidence that if you multiply them together under the radical and then do the square root of it, that it's 6 too?
Oh no, the problem is, if you multiply them together first, you get the square root of 36, and the square root of 36 is 6. And what was our answer supposed to be? Yeah, so, no, it's not coincidence at all. The problem is, you lose that negative when you do that. So we always, always, always do the I thing first. Always do the I thing first. If you can have an I, and if you can take an I out, do that first.
So like, what if they weren't perfect squares, like 4 and 9? What if there was 5 and 7?
Then you would have, if you had the square root of negative 5 times the square root of negative 7, you'd have I root 5 times I root 7, which would be I squared root 35, or negative root 35. It just isn't a perfect square, it's just a radical. All right, we have one more to do, one more section to do. Let's look at number 2. We're now on page 6. All right, let's look at this. Anybody want to take a wild guess? There's really no work to show. You can look at this one and tell me the answer. Anybody have a thought? Mr. Brokaw.
If you're looking for x, plug in 0 to all the y.
Oh. It's an interesting concept. No. But I can see where that logic is coming from. It's good, a good thought. But no, that's not what we're going to do. Think about this for a second. In this number, right here, if you look at just the side, you have a plain number and then you have something hooked to the I. Over here, do we have a plain number and something hooked to the I? Yeah. If those two are equal, think about it. Doesn't it make sense that these two would be equal? And these two would be equal? So what does x equal? 3. And what does y equal? 2. If, now I'm going to throw a bunch of letters up here, but if a plus bi is equal to c plus di, then a has to equal c, and b has to equal b. In other words, the parts with no i's are equal, and the parts with i's are equal. Okay? Now, the next one is a little bit harder. Let's see if you can figure it out. 3 minus yi equals x plus 7i. Anybody tell me what x equals? 3. X equals 3.
Since y is a negative.
And y equals negative 7. Because negative y equals 7, so y equals negative 7. Are you okay with that?
Mm-hmm.
All right, on your own right now, we have a few minutes. Go skip down to number 4, part 4. Would you do those two problems for me? We've already practiced them,
Is that it?
so we're going to do part 4 now. We're down on number 4. You're going to do the FOIL, and you're going to do the conjugate.
Yes. And then it would just be 12 minus 36.
So I see, okay. So
There goes matter. All right, quickly, see if you can get these done. Ask me if you don't understand something.
21, negative 21 plus
Oh, yeah.
I love you.
Why is someone I didn't even care.
I could see you
Anybody have a question about either one that's on the board? Lindsay? You got the same thing I did? We matched. Your homework tonight's in P6.